So we're doing homework 7, but we're doing it as an in-class assignment for those who came to class. Thank you very much. We've done the ask function here. These lines of code correspond with these lines in the flowchart. Now let's do this one. I put the start message here. Usually I call it main, but since I knew we were going to call it a flowchart, I put start to indicate that we're going to put a start oval over here. And then what's the next line of code? It's the print X. Yeah, it's the print, it's the ask, and then it's the print, and then it's the ask. And some people want to take some kind of shortcut and put these, on either side of the start statement to try to block them off together. You can't really do that. We just have to put them in the sequence that they appear. And if you have two print statements in a row, like here, I don't mind if they go in the same box because they're doing the same thing. Just like if you have two calculations in a row, you could put those in the same box. But when they're completely different statements, like that and that, you can't put them in the same box. So, print is a parallelogram.
I thought you had to put define ask first before you could put in.
I've got define ask over here. The function is defined here.
So how come you don't put it underneath it?
Yeah, well, how come you?
Because isn't it part of the same main program?
No, the ask function is not part of the same program. I mean, it's part of the code source file. Just like when we did the guessing game, the ask function was over here and the main program uses it. And if it's bugging you, the ask is on this side rather than this side, we can move the ask function over. I can come over here and I can just, come back out, highlight all this stuff, bring that over here, and then pull the main over here. That makes it look more like the flowcharts that we've already done.
That's not what it was meaning.
I didn't think it was, I'm sorry, but I'm not answering your question well.
You're fine. I meant isn't the define ask supposed to go in your main code so you know that you're referencing to that code?
No, the way I do it is I print my message here because this is the actual first line of code in the program. This is a function that's defined, and that could be defined even in another file. The execution begins here because it's the first unindented line of code that's not a DEF. So I print a message, then when I want to use this line of code, I invoke it with the box with the vertical lines, and I say X is equal to ask. And I get where you're going with your question, I think, but maybe this will help. And then usually, to make things super clear, and you don't have to do this at all, I color code my DEF ask statement over there with the paint bucket. And then I color code the call to it with the same color. So the reason why I didn't have to put DEF ask here, the function's already been defined. We only use the DEF keyword for a specific function once in the code. So in the code that was shown here, but to use it, we can use it as many times as we want to. We use it here, and we use it here, and we use it here, and we use it here. We don't need to redefine it each time, so we don't need that DEF keyword multiple times. Does that make sense?
Yeah.
Okay, yeah, so we don't have to redefine our function. I don't know if you're a C programmer. If you're a C programmer, you have to do something called a prototype of the function, and you have to define your prototype before you can actually use it. But in Python, just simply having this defined in the same source file or a file that you import is enough. Okay, so looking at our code, the next thing it does is print enter y, and then y is equal to ask. Those two lines of code are going to be exactly like this. This one said enter x, x is equal to ask. The next one is going to be enter y, y is equal to ask. I'm going to cheat and copy those two things. I'm going to highlight them, go up to the menu, choose edit copy, edit paste, I'm going to pull those bad boys down there. That just saved me a little bit of time. Of course, I have to change the text here. Enter y, and then y is equal to ask. And again, you don't need to make any particular effort to squish these as closely together as I do. All right, so who has the homework assignment open? And what's the next statement after the x is equal to ask and the y is equal to ask?
The while statement.
Yeah, we got a while loop. What kind of shape does a while loop go in?
Diamond.
Yeah, a diamond, just like an if statement. But to indicate that it's a while loop, I actually put the word while in there. According to official flowcharting rules, if you go look on the internet for other examples, you won't always see that word while. So while x is not equal to y, you also don't have to put the colon there, but the colon's in the code, so I put it there. While x is not equal to y, do this code. And in general, anytime I indent, I make my flowchart go off to the right, with one exception, the else statement. So I'm going to draw no shape can have two lines leading away from it, except for the diamond. The diamond can have a yes and a no, or a true and a false. The rest of them can only have one line leading away from them. So if you draw like a parallelogram and then you have two lines going away from it, that's not right, because if you were tracing through the program, you wouldn't know which way it was supposed to go. But now we do know which way it's going to go because it's a conditional statement. It's either going to evaluate the true or false. So that's going to be the true. I'll just make that go down here for the false, and who cares what that does at this point, because we're going to work on the code that's indented. This goes off to the right, so it's the indented code. So we print some messages. They don't match, try again, enter X. All right, well, here's two print statements in a row. I don't mind saving space and time and putting them both in the same parallelogram. Print, they don't match. And then Control Enter to start a new line. Print, try again. Or no, enter X. And that doesn't look very good, but box needs to be wider and all that. Not going to take 20 minutes to make a perfect flowchart. Okay. So what's the next line of code after the enter X? It's the ask statement. What shape do we put the ask statement in? It's a call to a function that's defined elsewhere in our program.
Box.
So it's going to be a box at the bars. Yeah. And if we look here, this enter y and this y equal ask really are the same thing as they were up here. So again, I could copy and paste them. I'm just going to grab that enter y and y is equal to ask. I'm seeing some duplicate code here. These 4 lines of code and these 4 lines of code are duplicated. If I put some thought into it, I could revise the logic of it so that we did not have that duplicated code. That might be a topic. Yeah, after this we'll take this guessing game program and we'll modify it. Well, it's not a guessing game, it's just a number matching game. To eliminate the need for the duplicate input. Alrighty. And now we're at the end of the loop. How do we indicate that we're at the end of the loop?
Circle back to the.
Yeah, we're going to circle back up to here. And I don't mind using a little bitty connector symbol in order to indicate that we're at the end of the loop. Sometimes I think that's pretty cool, but it's certainly not necessary. I usually only use a circle if I have multiple things hooking together. you know, coming together in an intersection. But if it makes it easier to draw, I'm not sure it does. That did something wiggy. Not liking that. I'm going to delete that. I'm going to delete the circle. I'm going to delete this line, and I'm going to draw the line from the side of the ask box. See if that makes it look better. Yeah, that's better. Once you select things, you can move them around with the cursor keys, which is kind of cool. Okay, so that's the end of our indented code. This code is not indented, so this is the code that drops straight down from the while loop. And I like to try to keep my indentations lined up. I would like to put these two print statements so that they are vertically under the while statement, but that's going to require drawing a great big line down here. That's okay, but then my flowcharts become very long. You know, according to flowcharts, it doesn't matter. You can make all your code, you know, start from the bottom and then go up as long as your arrows go that way, or you can make your code go in a spiral or whatever. But I try to make mine look like the program, so I wind up with very vertically oriented flowcharts. All right, enough talk. Let's print they match and done. Those are two print statements. They're the same thing, so I could just combine them in one box. And like I said, I like to try to align my unindented code together. So since this is under the while box, I'm drawing this under the while statement. Since these print statements match that in indentation level, I'm putting this directly under the while box. Now that line's got a weird little curve to it, but we can fix all those lines just by choosing a theme. If I choose a theme, it'll probably erase my color, but who cares? Okay, so print, they match, and then print done. So Control Enter to start a new line. I mean, really, why do we have that second print statement? But I always ended all my things in a print done. Some people want to put the last print done in a statement like that, but no, this is just a stop. It's not even a programming command. It just matches it's like the X on the map. There's no X in real life when you get to that point on the map. So there's no stop command in your program. All right, I can fix this weird curvy line here by going up into my menu and choosing Edit Line Type, which is between the pencil and those little curvy block things. And I'm going to just say I want it to be a straight line. That's the only one that's bugging me out of this. And I hope you understood what I mean about the placement of the blocks being not totally important. If I really wanted to squeeze the space of it, I could do that. I mean, don't do what I'm doing. I'm making it look stupid, you know. And if there was some reason to, I could make these go in a diagonal line. You know, as long as the arrows are right, it's totally cool. But since I do my flowcharts usually for students to type code in from, I find it easier for them to type in code if I make these match the indentation levels. Because that would make it look like you're going to indent there. Nah, we're not going to indent there. Okay, so that's our flowchart. What do I not like about the way that I wrote this program? If I'd been thinking hard, I would have written it a different way. Oh, I forgot to color my ask statement. Here we go. Make that blue too as well. Don't need to. That's not a requirement. Just I like to do that to eyeball it. Here's what I don't like about it. I have the same code duplicated in two different places. I have enter X, I have that box, that box, that box, and that box in two places in the flowchart. I can't fix that. It's just in the flowchart. Some people want to make this go back up here and do that again. Well, the code's not written that way. The flowchart has to match the code. But we could change the program. We could change the logic of the program so that we only have one set of ask statements rather than two. So if we do that, thematically, we are making it to where it goes back up there. But let's do it in the code. I actually think better in code than I do in flowcharts. And that's true of a lot of programmers. I bet that a lot of y'all are not going to, you know, pick up the pen and paper and start drawing flowcharts after you get out of this class. But it's a good way of figuring out your program. Where's all that coming from? I don't know where that's coming from. Okay. Let's hope that I can copy and paste this code into an idle window. You can't always copy and paste out of PDFs successfully. If not, I'll get it in real fast. Okay, it looks like it worked, but the indentation levels were all lost. I'm going to correct the indentation levels. So if you want to play along with me on this, which is not necessary, copy that code from the PDF, paste it. How do we know when to start indenting? Anytime we see a colon, we know we need to start indenting. Where's the next place I'm going to start indenting?
Underneath the wall.
Yeah, right down here. All right, let's see if that works. Homework7.py. And I did what I keep lecturing y'all not to do, which is to try to save it in the Python directory. Sometimes when you copy code out of a Word document or a PDF, it gets invisible symbols embedded in it, which totally blow apart you trying to run the program. Looks like this worked. Enter 100, enter 200, they don't match, try again. Enter 200, enter 200. So it's kind of a variant of the guessing game, but it's not real challenging, is it? The idea was to get a flowchart from it, not to make a good game that people would want to play. But our task, I don't like having these two things be duplicated. So what I'm going to do is I'm just going to say while true. What a while true is it's an infinite loop that repeats until you see a break statement in the code. And a break statement exits the while loop. So what I did is I changed, if you were playing along, I'm going to delete these 4 lines between the start and the while loop. I'm going to change that to while true. Has to be a capital T, unlike a lot of other programming languages. Now I don't want it just saying they don't match, try again right off the bat. That's kind of dumb. I'm going to cut that because I'm going to paste it or type it in later. Okay, so inside my while loop, I need to check to see if they match. And if they do match, I need to break. So if x is equal to y, break. Because they matched. Else, print they don't match, try again. I'm going to take that try again off. It'll be easier to flowchart it. Okay. So this is a little bit different because our while loops in the past, I think I've actually shown you this in code before, but our while loops in the past keep going. They keep repeating as long as this condition is true. But what happens if you stick the true word there? It'll keep repeating forever. It's an infinite loop except for the fact that we have accompanied it with a break statement. The break statement causes it to exit the while loop and go to the first unindented code. So we've traded some complexity. By removing those 4 statements up at the top and only having them here in one place rather than 2, that complexity was reduced, but then we had some additional logic here to decide if we were going to break. So by trying to minimize the input code, make sure that I didn't have code duplication, I actually made this logic a little bit more complicated. But let's make sure this works still. Enter number 100, enter number 101, they don't match. Okay, enter number 100, 100, they match. Okay, so that's the same program, logic-wise, functionality, but it's not the same program, you know, looking at the code. And if we had to flowchart it, which I'm going to go ahead and draw the flowchart for, I think I'm just going to copy the flowchart we already have, and I'm going to paste it, and then I'm going to modify it. So I'm going to bang this over to the side. Go back to my flowchart. That's a lot to copy. If I zoom way out, I can copy it. I'm going to move this ask statement back over here where he's not in the way. The way I zoomed out is with the control key. You hold control and then you spin the mouse wheel and you can zoom out, you can zoom in, which is the topic of the assignment that we're going to be doing called scaling and shifting. This is scaling. Scaling is when the program changes the coordinates of the picture that it's drawing to make it smaller, to make it bigger. And shifting is when it's changing the coordinates to move them left or right. Because right now, you know, that might be a position 100, 200, with 200 being the y coordinate. You know, it's 200 pixels down from here. But if I scroll and I move it down here, now it's at 100, 400. I had to mathematically adjust the coordinates of this thing in order to draw it accurately. So when you have a set of coordinates and then you want to display them on screen in an XY format, and you want to allow the user, or you want your program to be able to position it on the screen, you have to scale the coordinates and you have to shift them to put them in the right place. If you shift them wrong, you wind up with that. If you scale them wrong, you wind up with that. Or, you know, zoomed in. Okay, so you don't have to draw this duplicate flowchart, but if you want to, it'll be cool. This is the alternate logic that we just coded. I'm going to select it all, copy it, then I'm going to paste it. So this is the second version of it. And what did we see me do? We saw me delete the first 4 lines of my code. Boom, they're gone. And then instead of while x not equal to y, what did I make my while loop say instead?
True.
Yeah, it was just while true. Now this no longer says they don't match, because we don't want to say they don't match right away as soon as we start doing the program. So I'm going to delete that first print statement, but I'm going to leave the one that says enter x, because that matches the code. Right, if we look at the code here, hey, come on, idle, where are you? There we go. So under while, we indent, it says print enter x. We ask for that, x is equal to ask. The next line is print enter y. And then we call the ask function again. Now the program has changed a little bit. Now we have an if statement. If statements are diamond blocks. If x is equal to y, then we're going to make a break. We make a break just by drawing an arrow and jutting it off like that, and we put a word break over here. Else, I like to change the word no to else if it actually is an else statement, but you don't have to do that. And I also like to draw the line off to the left, just so it really hammers in that it's an else rather than a drop straight down. Because if you drop straight down after an if statement, then there's no conditional code underneath it. There is no else clause. All right. We print they don't match. I'm going to copy and paste one of these. I'm copying and pasting really fast with Control C, Control V, but I tried that on a lab computer and it complained that, no, it said I had to do it that way and I couldn't use the menus. It kind of confused me. Okay, so print they don't match. Now what needs to happen, this has to go back up to the while loop. It has to loop again. And that looks bad, so I'm going to try making the line go out from the side instead. Okay, the thing about infinite loops like this is that there's no line coming from them. There's no way that this cannot be true. So we can't have a no line. then where does the stop command come from? Let's just draw it coming from the break statement. Now this looks wacky compared to the flowcharts that we've drawn already. What's looking weird about it is the lines are not coming out of the while loop. Instead, they're coming out, one line is coming out from the while loop rather than two. Oh, I had some statements down here. Print their match and then they're done. So I need to put a parallelogram that says that. And it needs to go above the stop statement. So I'm going to delete my little curve there. Drag the stop underneath it. Put a parallelogram there that says print they match. I'm going to combine those two print statements into one just because I don't feel like drawing two boxes or whatever. Okay, I'm going to do some shuffling around to try to get the lines bigger. Make it more visible on the screen so I can get up there and lecture about it. I'm going to make this one a right angle line so that it doesn't cut through that one. So I'm going to go up to the tools and choose edit line type and make them a right angle line. If you don't like that line jutting out to the side, it's totally okay to make it go straight down, but I would strongly recommend that you use the word else there to key the next programmer in that they're using an else statement. This one could also be a straight line to make it pretty. How successful have I been in getting all this to fit in one place? Oh, that's a little better. Okay. So compare the two programs, the before and the after. The big change is that we don't have this duplicate code block. Here we had the ask statements in two different places. Here they're only in one place. That's one big change. The other big change is that in order for us to escape from this while loop, we used a break. Now we could jigger it in a different way so that it was a traditional while loop, but it would involve setting a variable, that was true, and then when we were done looping, we would set it to false and it would go down there. I like for y'all to see the idea of a break, so that's why I went ahead and did it in this slightly different fashion. Did we do breaks already in a previous class, or is this our first one? Okay, good. Then I'll stop blathering about it. So our difference is by eliminating the duplicate blocks of code. Why do you care about eliminating duplicate blocks of code? Because if you have duplicate blocks of code in your program and then you need to change them, you have to change them in multiple places. And if you give the code to somebody else who's not familiar with the structure of your code, then they may not get to all the changes. You'll remember, oh, I need to do that and I need to do that. So really, if you have duplicate blocks of code, what you need to do is either find a way to move that code into its own function, like this, or to revise your logic so that they do not appear twice. And in this case, I thought it was easier to revise the logic so that the code was not duplicated. Now, sometimes you can't do that. We may have this code that needs to ask user for input. Like suppose you had a input routine that needed to ask the user for an integer, and you wanted to absolute flatly guarantee it was an integer. Then you might make a function for it. Well, that's actually what this kind of does, because your code may ask in 1,000 different places for that value. And when you have that duplicated all throughout there, and then you decide you want to change it to allow floating point numbers as well, then you have a problem. You have to search through your code for 1,000 different places in order to modify all your statements that do that. Whereas if you can encapsulate it in a function like that, you're better off. So that was the one change, was reducing the duplicate input block. The expense came at a little bit of complexity here. It's not really that more, it's not any more complex functionally. The computer thinks it's the same. But when we drew it, you know, it did not look the way that our flowcharts have drawn. The chief change is that our while only had one line coming from it rather than two, because the condition was always true. There's no other way for us to escape the while block except through any break statements. And you can put more than one, you know. If they say x is equal to ask and they type no way, you could have another break statement there. Okay, so let's go back to our Cartesian assignment. I think we have time to do that. Yeah, we have about 30 minutes, so let's... Did everybody find it? I put it in the in-class rather than the homework. I can put it in the homework as well, but it's in the in-class assignment. You can go ahead and save your document and upload that into the homework. We'll just treat this as an in-class assignment, but you get homework credit for it. You just choose File, Download As, and I'd rather have it as a PDF, but you could download it as anything. If you were going to paste this flowchart into a Word document, like I sometimes do, you could save it as an image, a PNG or a JPEG. Save it. If it gives you a chance to name it, that's great. Sometimes it just downloads it without giving you a chance to name it. Okay. So our final goal is to take our face drawing program and to be able to do this to it. Draw a fancier face, the teddy bear face, rather than just a smiley face with bullet holes for teeth. So what we're going to do is, in the in-class portion of it, if you scroll down, page 3, page 4, page 5, page 6, page 7. This is the source code that I want you to use. Rather than your own face drawing program, I want you to copy this code out of it and paste it into an idle program. But then I don't want you to touch it for a while because we're going to lecture about it before we start making any changes. Don't just go wild trying to draw the bear, you know, eyeballing it. We're going to get very precise with it. So I'm going to stick that code in an idle program, File, New, Paste, Save As, call it bear.py. Okay, so we already know how to draw this, and we already know what the coordinates mean, but we haven't talked about shifting and scaling. That's the topic of the lecture. So let me reopen this, go back up here. So the Cartesian plane. The Cartesian plane is a system for measuring, you know, positions with XY pairs. And we already have that idea. X's go across the horizontal, Y's go up the vertical. So we have two scales and two axes. Our final goal will be able to draw this. Now he's not superimposed on the graph, so it's not going to be easy to draw him if we did not have the graph. But I've included in a later slide the graph. Okay, so using XY coordinates, what is the position of this yellow dot here? I had a place up here where we can fill it in.
10:30.
Yeah, it's at X value 10, Y value 30. So y'all have that idea, obviously. Now the circles we were drawing for our smiley face. I did some thinking about it and realized that our algorithm for drawing the circle, what it was is it always set itself going north first before it executed the circle. And so the circles, their origin point was actually over here, which may be counterintuitive. Maybe we would want it to start here or start here or start here. We could modify our code so that the circle, you know, orbited around a different origin point. But our code as is, without making any changes to it, the circles always have an origin point of their rightmost part. So when we go to do our final bear, I must have closed that document. When we do our final bear, we're going to have points, you know, here, 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 here. We're going to have to get the XY coordinates of each one of those points. And when we draw a circle, what else do we need besides the XY position of it? We also need the color. That's another piece. but what else?
Still.
Yeah, you need to know the radius, otherwise it doesn't know how big of a circle. So here's this circle. What are the xy coordinates of it? What's the radius of it? Yeah, 40 is the x, 20 is the y. Oops. You can kind of eyeball the radius. I mean, even if you couldn't get it exactly, sometimes it's easier just to take the diameter mentally and divide by 2. But I made this one pretty easy, 40 to 15, so that's, 40 to 25. Or if you did it from over here, 10 to 25. So that's a radius of 15. So when we draw our bear, I made a simplified version of the bear. And actually, we're going to go even further in simplifying it, I think. I think we're going to only draw the head and then the ears as part of the in-class assignment before we start working on the scaling and the shifting of it. But you have to draw them in the right order. What would happen if you drew the eyes and the mouth and then you drew the circle? It would erase the eyes and the mouth. No good. We want the ears to look like they're behind the head, so we're going to have to draw the ears before we draw the head. So the order eventually in which we draw a bear would be the ears, the head, and then the rest of these aren't going to matter as much as long as we don't cover up the pupils with the white. You have to arrange the objects in the order that they will be drawn on the screen so that they obscure each other correctly, so you don't hide the bear's mouth with the bear's head. So, our first target. We want to modify our program so that it draws 3 pieces. We want to draw the ear 1, the ear 2, and the head. What are the origin points of ear 1? The origin points and the radius of ear 1. What do they look like to you? Well, there's ear 1. What's his x value? About. Yeah, it looks like 24 or 25. What's his y value? I think it's above the 50 line, so I'm going to say 51. Yeah, you were counting, Okay, so I've already forgotten. What did I say? That was 24, 51. Yeah. Now the other ear we pretty much want at the same height. So I'm also going to say that its y coordinate is 51. I forgot to get the radius of this. I'm going to fill in the x coordinate for ear 2 and then go back and get the radiuses. All right, so that looks like it's at 76, 77. So let's say 76. So 76, 51. What do the radiuses of those ears look like there are? I got 10 up, but I don't believe that.
Looks like 10 to me.
Maybe it is.
It's 10.
Okay, cool. One more circle. I want us to get the head. He starts at, well, x coordinate 70, y coordinate 30, and he's got a radius of 30. 70, 30, 30. That's enough information to go into our circle program and actually put the code in that will draw him. I don't need my homework 7 assignment, but I do need my bear code. So if you copied and pasted it, remember the way that our bear code is structured is we had a relocate function that would set the x and a y coordinate, and then we had a circle function where you passed in an x and a y and a radius and a color. And it would move the turtle over to that position to the specified x and a y position. How did it relocate? How did it move? By using this function. Then it would draw a circle of the specified radius and of the specified color. And then down at the bottom, in the main code, I added a function called crosshairs. All it does is draw a horizontal and a vertical line at 0, 0. And that's so that we'll be able to see where the bear is compared to 0, 0. And that'll make a big difference when we start trying to shift him. Okay, so circle 150, 50 does not make any sense according to what we're drawing here. What should those values be? We're going to need 3 circles, right? One for ear 1, one for ear 2, and one for the head. I'm just going to change these values on the first one. The first one, come on, scale a little more cleanly. Here we go. 24, 51, with a radius of 10, and let's make him let's make him tan, or at least mine's going to be tan. If you want to make a Grateful Dead bear that's all the colors of the universe, feel free. And I'm going to put a comment as to what this is. This is ear 1. Now I don't feel like typing all that in again. I'm going to copy and paste it. Save myself a little bit of typing. That's going to be ear 2. That's going to be ear 3. Now change the coordinates of ear 2 and ear 3 to match the coordinates that are shown in our little spreadsheet here. Yep. I haven't done the second and the third circle, but
Okay.
I'm gonna modify those values so that they match
Okay.
those values. You may notice that this circle function now only supports one color. It makes the edge color, and it makes the fill color the same. And I did that just so that it would look more like it was cut out of construction paper and didn't have a thick crayon border around it. Okay, so the second circle started at 76, goes to 51 with a radius of 10. The third circle, 70, 30, radius of 30. There we go. Now when I run it, it should draw 3 circles. Unfortunately, they're going to be teensy weensy. Not real impressive. I'm not going to send that one home to Mom yet. So what do we need to do in order to make this more impressive without going back and changing these values, without going, okay, yeah, we're going to scale these guys. And I don't want to scale them by redrawing it on a different sheet of graph paper. I want to scale it by modifying our circle function. So everybody got these typed in so I can zoom the Word document in full screen? Maybe I can get that part of the code down here at the bottom. Okay. So first let's work on shifting it. And what I mean by shifting it is let's move it over so that it covers the crosshairs. Why is it not covering the crosshairs? Because in our graph, 0, 0 is in the middle of the screen. But on our graph paper, 0, 0 was on the edges. So we want to shift it. How are we going to do that? Well, we're going to subtract values from x. If we subtract enough values from x, we're going to move our bear from whatever position he is now to where his center is located on the center of the x-axis. And then we're going to do the same with the y. We're going to nudge him down until his center of his head or something close to it is at the 0 of the y-axis. So we're going to have to subtract values from x and y. So here's a circle, and here's a circle, and we need to decide what the shift values are going to be to move the blue circle onto the position of the pink circle. How do you do that? You just take the difference.
So minus 40, minus 30.
Yeah, so it's going to be 50 minus 10 is 40. So the x shifting is going to be 50 minus 10. And we could fill in this little chart if we so felt. Because coordinate C1, his x value is 50. His y value is 30. Circle C2 is at 10 and 0. So what's the difference between the two? 10 minus 50 minus 10. We want to apply a shift of 40. Minus 40 really to get them down. And then we want to apply a shift of 30. So we're going to modify the circle function because realistically the circle function is the only thing in this program that actually puts the pen to paper. So it's the one that needs to be modified. You might think that the relocate function also needs modification, but in this case we're going to do it the easy way. So up here in circle, we need to modify. Let's create two variables called shift x and shift y. And I could put them in the code here, or I could put them outside of the code so that they could be used by other functions, but we really don't have any other functions. So I'm going to make room for 4 lines. The shift x position value is, what did we decide that was? It was 40, right? Okay. And then the shift y value was equal to 30. Now we need to modify these x and these y values by those amounts. X is equal to x minus shift x. Y is equal to y minus shift y. Just make those changes and run it again. That should go a long way towards getting it in the center. If it doesn't, you know, we can play with those values further. And why did I do this rather than take 40 and 30 and just put them there? Because eventually we may want these variables shared by other things. You know, we may add some draw rectangles and draw you know, triangles and stuff like that, and we would need to be able to access that. Okay, let's go to. All right. The bear should be frightened. The crosshairs are on him.
How'd you get the crosshairs?
Look at this. There's a little function called crosshairs.
Oh, okay.
Yeah, and we call it in main before we start drawing the circles.
Okay.
And so all the crosshairs function does is it relocates it and then draws a horizontal line, and then it relocates it and it draws a vertical line.
Okay.
Okay, so we've achieved shifting him. But we want to achieve scaling him as well. So did everybody get the shift to work? I don't want to blaze on at light speed. Got it? Your shift X and shift Y working?
Oh,
All right. I'm going to cover this up, but then we'll go back to it, so you'll get to see the shift X and the shift Y code again if you don't already have it. Scaling. Say we have a line that goes from, let me scroll down to the bottom here, from negative 20 to positive 20. and negative 20 to positive 20. So this coordinate is negative 20, negative 20, and this coordinate is positive 20, positive 20. But we want to stretch it so that it fills up more space. So this is the original range, you know, that's triangle that line occupies. I could have narrowed it down to exactly where it was. But we're going to grab that line, we're going to stretch it so that it fills up more of the space. And so it's going to escape the bounds of the green box. There's our new line. That's how big I want our new line to be. So instead of going from negative 20 to positive 20, I want it to go from negative 40 to positive 40. So I'm going to have to modify the value of A1 to A2. And I'm going to have to modify the x and the y coordinates of B1 to BB2. Now you don't use plus and minus in order to shift. Instead, to scale. Instead you do multiply. So here, there's a little chart down here. And since we're going to scale it the same way, the same amount for x and the y, we only really need to calculate one scaling factor. If you're going to make it to where you could both squish it horizontally and vertically by different amounts, we would need two scaling factors. But we only need one. So let's see. What is B2's x coordinate? Yeah, it's 40. And B1's x coordinate is 20. And the formula for the scaling factor, assuming everything is zero oriented, is B2 divided by B1. So we have a scaling factor of 2. Now we're going to add that to our code as well with the shift functions. And it's not going to look perfect the first change because I'm going to intentionally leave something undone. But then you'll spot it very quickly. So along with shift x and shift y and scale, we need a new one called scale. And we decided that a scale of 2 would work. After we have calculated the new x and the new y, we need to multiply it by that scale. X is equal to x times 2. Y is equal to y times, not 2, by scale, by that variable name. Sorry, my mistake. And then run it again, and we will see that it kind of works, but not really, because there's one thing I'm forgetting to scale. There. Now what happened?
You get to scale the
That scale across it.
Yeah, we didn't scale the radiuses. So it's like the pieces of the bear are in better positions, but they're not doubled. The radius also needs to be doubled, and the radius of the head also needs to be doubled. We could do that too. Down here in all of this stuff, why don't we multiply radius by the scale? Radius is equal to radius times scale. Now I'm going to add some comments just to make this really clear. I mean, this is really actually probably pretty clear already. But shift XY to move to center. And then scale XY to make the bear larger. Scale the radius to match. With that done, I believe our bear is going to look a little bit better. My guess is that we're going to keep increasing the scale size, though. Okay. He's looking good. But change scale to 4. And then rerun it. Much better. Change scale to 0.1 and run it. He's the size of a bacteria. Because 0.1, we divided his size by 10. That was obviously pretty stupid. I think 5 is going to be my final answer. So when you play with a program like Paint, or Adobe Illustrator or Photoshop or something, as you're scrolling in and out, it's doing that math behind the scenes. Everything is stored with X and Y positions, but then when it's drawn on screen, it's shifted to where you have specified, and it is scaled to the current scale value. Because it doesn't make any sense to change the data in your document just because you're scrolling around. It's only when you start dragging things around, and making changes to your document that you want those to be saved. I want to see 5 run. I don't think I've tested it with 5. Cool deal. I think that's good. You can comment out the crosshairs if you think that's kind of disturbing, or you can make the bear large enough to hide it. I think 6 would hide it. So close. Whatever, 7? You don't have to hide the crosshairs. I'm just... Okay, that is the end of the in-class assignment. The homework, I'm going to upload this Word doc right here into the homework box. And so, if the face is tan, as we've done it, then a good color for the inner ears and the nose is sienna. You could try that right now. Go make his head sienna rather than tan, just to, Oh, let's add his nose before we go. The nose starts at, it looks like 20, looks like it's at 42, 26, 42, 26, and it looks like it has a radius of about 8. Can I remember that?
It's like 48. 48, I think you're looking at
Yeah, I'm sorry. 48, 26, 48, 26, 48, 26. Okay. So I'm going to add a 4th circle. Nose. Nose is at 48, 26, with a radius of 8. Or not. I forgot to change his color, so it drew it in sienna. It drew it in tan. Sienna, S-I-E-N-N-A. All right. If you want to find a different color, you can use Google to find a color chart. Find Python turtle color names. Just do that. Python turtle color names. And we should see a page, the very first hit, if it ever loads, of all these words. Now that doesn't help a lot, right? Because it doesn't actually show the color.
I just put in Python color chart.
That sounds good. That's cool. Like one of these. Then you'll see, a lot of different colors you can use. Want to make the ears almost white? Use papaya whip. Lemon chiffon. Whatever, whatever colors you want. I think I'll paste that into the Word doc. So go ahead and upload your code as is into the homework, into the in-class. But then you're going to base your homework on the same file. So make sure you take it home, put it on your drive, or you can re-download it again from the Dropbox. Mail it to yourself, whatever you have to do in order to work on it from home. Okay, if you didn't get the circle function finished, because I kept covering it up, it's there now. Let me pull that up. Let me get the homework document modified in the fashion that I wanted. Alright, you get that uploaded. I'll just take attendance based on